line of that fit versus the two data. What else in there? Another thing that's always important is to label your axes. Show what this represents and show what that represents. All right. Again, we'll break down the AP test by when we do some practice problems. We'll look at the scoring rubric, but that's always worth a point, is labeling your axes. All right. That's like the easiest point ever. If you don't label the axes, you don't get that point. All right. For one like this, you're close to the national average. You can graph the points for all line of best fitted and label your axes. You're already up to like 4 or 5 points. In a lot of these problems, the national average is like 6 out of 15. So if you can do like the basic stuff and understand where you get points, you'll be okay, even if you can't do a lot of these. Anything else under graph that jumped out at you? Highlighted those things. Number 6. We'll talk about number 7 when we have a better example. I think it'll make a lot more sense when we look at an example instead of like trying to explain that. We won't get to it today, but what we do in the lab is exactly what number 7 is talking about. All right. The last thing we're going to do today is work on the lab. The goal for that is to design an experiment, analyze that data to find the acceleration of the ball on the front. All right. So obviously, we want the ball is going to be accelerating as it moves downward. We're going to be taking some measurements to find what that acceleration is. But obviously, we shouldn't be getting a number greater than what. Ball as it slides down that incline. The fastest it could accelerate. Yeah, it can't be any faster than gravity, right? Because if it were just dropped with no incline at all, it wouldn't be accelerating any faster than gravity. And obviously, it's not going to be any less than 0. Yeah, it was all. Also, I'll tell you exactly what I want you to do on the lab, but we can go ahead and get our homework written down for it's on that sheet I passed out to you. I do have every one of you for calculus or probability. Yeah. Also, the parent information sheet has double one for that side. So I don't need to pass those out. So your homework, pretty easy homework, pretty short homework. It is on your outline, page 19, 17 to 24, 39, and 41. That outline is very tentative. I just looked real closely at the school schedule, so we have a little short various a day or two. Subject to change. Was that a common theme?
Well, for the end of the year, on the outline of the
yeah, very simple. Well, I have something out to you. We are not, no. No, not a chance. All right. These things here, time them. I think you guys have dealt with these times before. I think we did 8 altitude maybe last year. Everybody come up here real quick. There's a little bit of a change. And that's actually a little different than what it says up here. All right. This says that one of the timers is fixed at the 5 centimeter mark. It wouldn't fit on the 5 centimeter mark. So it's down here at 10. And then all the other ones, obviously, that are bumped up by 5. So that's 15. What we want is to figure out how long it takes to move 5 centimeters. So to begin with, we're going from 10 to 15. We don't want to start it up here when other than the 10 to good, because then it's going to have an initial block. We want its initial block to be 0. All right. So when you're doing this, A and B both have to be on. The system is so close to the timer, as you're putting that down, notice it registers it right there. So your partner's going to push reset. So, and then you can watch. That makes sense. All right. So you're probably going to have to hit reset. Also, if the ball is in there, there is, there it is. a little light that will change to red. So you need to make sure it's on green so that it's not in the middle of it. Make sure it's green, then hit reset, and then it's done. All right. So you're going to maybe run 2 or 3 trials to make sure it's consistent, and then you're going to move this one down 5 centimeters. To do it again. All right. So our distance traveled is not necessarily the distance on this, it's how far it is from the 10 centimeters. Make sense? No. Excellent. We can have 8 of you, 2 groups of 3 and a group of 2. Find a spot. The goal for today is to complete the entire front side. 2 groups of 3, and a group of 2. I said that right, didn't I?
Yeah, I think so.
Okay. You only have to do the front side. The back side that you know what you can try to do. I want to talk about that next class.
All right, let's go.
I know I can.